is you go straight to the formulas. You start writing stuff down without thinking about what you're actually going to do. When you write this becomes super easy, doesn't it? It's the surface area of a prism formula, 2 WH plus HL plus LW, right? Minus 2 pi r squared, right? Plus 2 pi RH. Now you can fill it in because you have all the numbers. Now if you fill all that in, you show me all that, that gets you the 3, the meeting expectations? Does it? Sure it does, right? So you would go ahead and fill all that in with all your numbers. WH, HL, LW. So 50 times 40, which is 2,000. 50 times 30, which is 1,500. And 30 times 40, which is 1,200. And all that would be doubled. So that's 3,500, 4,700 times 2, 9,400. Minus 2 pi r squared. What's the r? 7.5, right? So 2 pi 7.5 squared, which is whatever it is. I don't have my calculator. Plus 2 pi r, which is 7.5, times h, which is 30. Then you would just do the math. And you just punch that into your calculator. Now, if you don't get this, what does that tell me? Does that tell me you can't do math, or does that tell me you need more calculator practice? More calculator practice. Is this calculator 10? Is it? When you signed up for this math course, did you see calculator 10? No, you saw foundations and pre-calculus mathematics 10. So what's more important to me? This or this? This. Okay? And then volume, of course, you don't need to worry about it because it's one volume minus the other volume. There's no volume added, right? It's removed. It's gone. You didn't create any new volume, but you did create a new surface. Everybody understand? All right. And so volume, of course, it would have been LWH minus pi r squared h to get that. So the top of the cone, again, before you do any math, have a plan of attack. What is this drawing I have drawn? It is a big cone, which I'm going to draw in red. And what's happening? The top's cut off, right? So, if I had a giant pile of money and I took off part of the top of it, what math would you do? Subtraction. What would you subtract? The giant pile of money minus what I took off, yes? So it's the same thing here. I have a giant cone minus the small cone. The area of the giant cone is pi r squared plus pi r slant, yes? Minus, what am I taking off? I'll draw that in green. So what's coming off? A cone, which is pi r squared, pi r slant, yes? Except, what did I make right there? A circle. So am I removing the pi r squared, the pi r slant, or both of it? Only the pi r slant, yes? I am adding the pi r squared from the green, but I'm subtracting the pi r s from the green. Everybody understand? Math, not hard. Add and subtract. Seeing it, difficult. Which is why I give you so much practice. Right? Now, what's the problem with this? Do we know the slants? Of course not. What do we use to find slant every single time? Pythagoras. So the first slant in red is 9, 12 to get that slant. What is it? I'll give you a hint. 3, 4, 5. The 9 is 3 times bigger, so what's the 5 now? It is 15. So pi times 9 squared plus pi times 9 times 15 plus pi, my green r is 3 squared minus pi times 3, and what's my green slant? 5. Now I just do math. 81 pi plus 9 times 15 is 135 pi plus 9 pi minus 15 pi, right? 81 plus 9 is 90. 90 plus 135 is 245 minus 15 pies, which is what? 230 pi. Can I leave it like that? That get you all the marks that I could possibly give you? Yeah, no, that would get you all the marks I could possibly give you. Everybody cool? Well, again, what's happening? What did I start with? A giant pile of money shaped like a cone. If this giant pile of money was worth $1,000 and I took out $150, what would be left? 1,000 for the big cone. I'll make it easier. Forget the 50. I take out $200. What's left? How did you know that? I started with 1,000. I removed 200. Okay, so what do I have here? I have a big cone that has a certain volume, doesn't it? And I removed that much of it. So what math do I do? Minus. I had the volume of the big cone, which is pi r squared h divided by 3. And I removed the volume of the little cone. Done. Do I know all that stuff? Right. What is the r of the big cone? 9. What's the height of the big cone? 12 divided by 3. Minus pi, what's the r of the little cone? 3 squared. Times, what's the height of the little cone? 4 divided by 3. 81 times 12 is a big number. I can't do it in my head. Well, I can. It's 810 plus 162 is 972 pi. So that is 972 pi divided by 3, which is 324 pi. 324 pi minus 9 times 4 is 36 pi divided by 3 is 12 pi. 324 minus 12 is 312 pi. Right? Why does math exist? It exists to explain the real world. Right? So as soon as I gave you the giant pile of money thing, everybody could do it, right? Because you have a giant pile of money, there's $1,000 inside that pile. Take out 200 of it, it's minus. Right? Yeah. Is it? I added it in my head. If it's 210, it's 210. 81 and 9 is 90. 90 plus 135 is 225. Yes, 210. I did 110 plus. Yeah. Thank you. Everybody good? Excellent. And then this one. again, what's happening? It's a cylinder cut in half, yeah? So, always start with surface area because it's harder. What's the surface area of a cylinder? Plus 2 pi RH, yes? But it's been cut in half, hasn't it? So what do? Divide by 2. 2, 2, 2. What happens to them all? What's 2 divided by 2? 0? 1. So this is pi r squared, yes? Plus, what's 2 divided by 2? 1. So pi RH. Now here's where all you screw up. Here is a proper cylinder, yes? 2 pi r squared, 2 pi r h is what? It's all this, isn't it? It's only outside the cylinder, right? Think of a Coke can, where the word Coke is, and all the lies about how it's not bad for you, are all written on the outside, aren't they? So surface area only covers the outside, yes? So half the surface area only covers the outside. Does it cover that? Yes or no? Of course not, because that was inside the original cylinder, wasn't it? Right? So, since this is new surface, what must I do? Add it to the surface area. And what shape did I just color in? A rectangle, which is length times width. Then I just fill in my numbers. Pi r squared plus pi rh plus LW. Now, what will mess you up? Where is h? What is h here? 12. Because the cylinder is lying down. But if it stands up, its height is right here. Just like when you lie down, you're still 5 foot, blah, 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 or 6 foot, blah, 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 tall. I don't think anybody in the room is 4, blah, 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 tall. Although I did once teach a girl that was 4'10" in grade 12. She was so mad because if she'd been 4'9", it would have qualified as disability. But she was 4'10". She was so mad. I didn't know really what to tell her. Right? Like, yeah. Sorry, you're not disabled. Right? She said that. I don't know if it was true, but it sounded good at the time. Then you just do math and get the answer, yes? Right? So pi r squared is 64 pi plus pi rh is 8 times 12 is 96 pi plus 12 times 16, which is 160 pi plus 192. And you could leave it like that or you could multiply it out. And then, of course, for volume, I have this cylinder filled with money. I cut the cylinder in half. What happens to the amount of money inside it? It's cut in half. So I find the volume of the cylinder, which is the same as every prism, pi r squared h divided by 2, which is 64 times 12 divided by 2. So 640 plus 128, 768 divided by 2, which is 389. Right? I'm going to check with Gagan. 768 divided by 2? Well, your calculator's in your hand. You were the one that busted me last time. 384. See, damn it, it was 384. Good thing we checked. Everybody good? Hemisphere, I don't even want to bother with because you've got a formula for it. Right? For volume, It's 4 pi r cubed over, 2 pi r cubed over 3. That's for volume. And surface area is 3 pi r squared. I gave you those formulas in your notes. You should have just been able to fill them in. And lastly, this question is a problem. Because I found out, even though we live in Abbotsford, which is a farming community, I found out when I first gave this question years ago, a great many of my students don't actually know what a silo is. I know, right? So, I had to change, and I added this part of the work of it. A silo is composed of a hemisphere on top of a cylinder. And still kids are like, what? And I was like, okay. What's a cylinder? It's like this thing. What's a hemisphere? Like half a ball. Put it on top. What? And I was like, okay, kid. So I've left it in so I can tell that story. I don't like drawing it because it looks naughty. But volume. What's the volume of a cylinder? Pi r squared h. What's the volume of a hemisphere? 2 pi r cubed over 3. What do you do with those two numbers? Add them up, because it's a cylinder and a hemisphere. Right? Everybody good? Now, just out of curiosity, just to see if you've really been paying attention, I will draw this. And there's a door there. And there's usually a window up here to dump the grain in. And then it's got to be red or it doesn't count. And then there's like a cow here. And let's just give it some cow spots. You want me to make it a bull?
Sure.
You don't want me to make it a bull. Cows have horns too. And maybe there's a chicken. All right, maybe there's a farmer, and he's, of course, wearing blue overalls, because all farmers wear blue overalls.
Well, you kind of need like a fence, because like that chicken's just going to dip.
Right, and then there's the farmer, and he's not wearing a shirt, and he's wearing green gum boots, because he's a farmer. That's blue. He's wearing green gum boots, because he's a farmer. Awfully sexist of me to make the farmer a man, sorry. Plenty of lady farmers in the world. And there's his head, and he's wearing a straw hat, which is yellow. Now he's the guy from Curious George. The man in the yellow hat. Anybody? Curious George?
Yeah.
Curious little monkey? Okay. I don't really... It's not to scale. The farmer is much closer to us than the silo and the chicken. And the chicken is much closer to us than the cow. Because if a chicken were that size, you could really see that birds came from dinosaurs. Anyway, what if I wanted the surface area? It's only this, right? Which is the sides of a cylinder, right? So which part of 2 pi r squared plus 2 pi r h would you use? Just that part, right? And it's only this part up here, yes? And if the formula for a hemisphere is 3 pi r squared, would you do 3 pi r squared? No, because you're not counting that circle under there, are you? So you would just do 2 pi r squared. Everybody good? Sweet. Okay, quiz tomorrow on this stuff. What am I doing for you? Page 38, 39, 40. These are brain teasers, to say the least. You must know what you are doing with other shapes to do these. Okay? Everybody with me? You know how to do all of these. These are the type of questions that could show up on a test. Because there is no, find the formula, fill it in. You have to think about every one of the questions. Everybody cool? Do you have to work by yourself? Of course not. That's crazy talk. 2, 3, 4 brains are better than 1. Work together. Do not do that thing where you get with a group of 4 and say, I'll do number 1, you do number 2, you do number 3, and you do number 4. That's the dumbest way to do these. Don't do that. Okay? Go. Yes.